All right, guys. Day 17, last day of graphing, last day of the unit, and last video of the year. Okay, look at that. Congratulations. All right, this one's a little bit more different, a little bit more difficult than the last couple have been. Okay, I am not going to have you guys fill in a full chart. Okay, because depending on what the equation is, you could get lost pretty quickly filling in the chart. Okay, so for this specific examples, I am not going to have you fill in the chart. So let me just review what we've been through, where it's okay to fill into a chart. We have graphed things that are r equals any number. And remember, that is a circle. So all points are 3 units away from the origin. Okay. Then we went into these equations, r equals 4 cosine theta, where there's just a number out in front. And again, those were circles. Even if I change cosine to sine, it's still a circle, right? The 4 just told me how far out it came. Cosine tells me it's on the x-axis. Sine tells me the circle is going to be somewhere on the y-axis, okay? And then last time we watched the video, we had minuses and pluses in there. Okay, so something like that, something like 2 plus, 2 minus, that was going to be your heart graphs. Okay, those are your heart graphs. Now we come to our fourth and final type. And again, all 3 of these I would use a chart for. All right, if a chart is provided, use it. Okay, the following ones we're going to do now are we're still going to have a number in front. But now you're going to see a number between the sine or cosine and the theta. No pluses or minuses here. All right, you're just going to see a number in front of the theta, which is new to us. And again, I am not going to have you guys use a chart here to use. Okay, no chart here. Okay, so I'm going to have to show you guys some stuff based on, hey, what's this number tell me? What's this number tell me? Okay, first off, these equations are going to form a graph that I'm going to refer to as rose petals. You had circles, you had hearts. Now these type where there's a number in front of theta, we're going to call rose petals. Okay? Number 1, how can you tell how many petals are going to be on the graph? All right, how can you tell? It all depends on this number right here, okay? If even, okay, if that number's even, you are going to have 2 times that number of rose petals. Okay? So in this case, since it's even, I do 2 times 2. So that tells me in this graph, I'm going to have 4 petals. All right, 4 petals. If it's odd, that will be the number of petals automatically. So let's say there's a 3 in there, you're going to have 3 petals. If it's 5, you're going to have 5 petals. All right? So that number will tell you how many petals you're going to have. All right? Now let's talk about what is the deal with the number out in front. That number out in front means the same thing as it did for the circle equations. That tells you how far out the petal will go. All right, so we're going to go out to 4 units from the origin. Okay, so 4 petals, 4 units away from the origin. Now, the only thing we need to figure out is how far spaced out they will be. All right, how far spaced out they'll be. So since we have 4 petals, ready? Follow along here with me. It'll get better as we do more. Since we have 4 petals, and if you go all the way around the polar graph, you're going how many degrees? 360, right? So 360 divided by 4 petals, each petal should be 90 degrees apart. Okay? Each petal should be 90 degrees apart. Now, here comes the strange thing. Where do you start the petal then? Do you start it at 0 degrees? Do I start it at 90? Where do I start these petals? Good question. Now it all depends, and I know I'm throwing a lot at you here, but hopefully it'll make sense once I do the graph. It all depends on if this is a sine or cosine graph. If it's a sine curve, it will start halfway in between how many degrees apart they are. So this is 90 degrees, so halfway would be at 45. Okay, 45 degrees. Okay, so here's what we're talking about. Let's go back up to the graph here. So I know I'm going to have 4 petals on this graph. Each of them are going to be 90 degrees apart, and they're going to go out to 4 from the origin. The first petal, will be at 45 degrees. So what I'm going to do is, remember 45 degrees, and you'll pick this up pretty quickly. Remember, it's halfway between 0 and 90. So that's going to be right here, 45. So I'm going to go 4 units away. 1, 2, 3, 4. So that's where 1 petal is going to be. And it always comes from the origin. Every petal starts from the origin. Now take a look. I don't know how wide this is going to be here. Take a look. I don't know how wide this is going to be. Is it that wide? Oh, no, don't do that. Okay. Is it going to be that wide? All right. So what I'm going to suggest is once you have the origin graphed and how far out it's going to go, please do the point to the left and to the right. So what I'm going to do is I'm going to get my graphing calculator and I'm going to plug in pi over 3 and pi over 6, the one to the left and right, to see what type of numbers I get. All right. So if you want to use the table for this, you can. So I get out my graphing calculator. And again, the first one doesn't make you great. You guys always know it makes you uncomfortable. So 4 sine, I'll do pi over 6 first. So alpha window, pi over 6. I get 2. All right, so at pi over 6, it's 2. So I can graph that one. So at pi over 6, I'm going to 2. So this will show me how wide the petal should be. All right, moving on. I got to do pi over 3 as well. So 4 sine, alpha window, pi over 3. About 3.4 and son of a gun. This is my fault, guys. My fault. I forgot. I didn't even type it in my calculator, right? Some of you guys are probably yelling at me. One jab, Carlino, one jab. Okay, let's go back to the drawing board there. 4 sine 2 times pi over 3. Forgot the 2 the other time. Pi over 3. There we go. So it's about 3.4, about 3.5, right? At pi over 6, it was about 3.5. Or pi over 3, it was about 3.5. So at pi over 3, I'm going to go 1, 2, 3.5. There we go. Now do the same thing, but for the one to the right, which is pi over 6. 4 sine 2 times alpha y equals pi over 6. Hey, look at that. It's also 3.5. So I go to 3.5 again. All right, ready? Here's our first petal. I know how wide it is, and it goes out to 4. There it is. There's our first petal. Remember, how many petals should we have? 2 times 2, 4 petals. And how far apart should they be? 360 divided by 4 petals, they should be 90 degrees apart. The toughest one is the first one to get. Now this is going to go quick. Watch. Now I got to go 90 degrees. Okay, so I'm going to go halfway between pi over 2 and pi. So let's see, that was 1, 2, 3, 1, 2, 3. So now I'm at 3 pi over 4. And how far out am I going to go? 4. 1, 2, 3, 4. And we don't and you know what, guys? I'm going to make this easy on you. We don't even have to check the one to the left and the right because it's going to be 3.5 again. They just keep repeating. All right, so 3.5 to the right, 3.5 to the left. Graph that beautiful petal in. There we go. Here we go. Go another 90 degrees. Go another 90 degrees. So let's see. 1, 2, There it is, 5 pi over 4. Graph it. So 4 units out. 1, 2, 3, 4. 3.5 to the right and 3.5 to the left. Third pedal done. I know I should have 4. Look at this beaut. All right, so let's keep going. Another 90 degrees. 1, 2, 3. I should be at 7 pi over 4. Graph it. 1, 2, 3, 4. Got it. 3.5 to the right, 3.5 to the left. And there it is. 4 pedals, equally spaced 90 degrees. And again, if it's a sine curve, if it's a sine graph, you got to take how far apart they are and divide by 2. That's how I knew to start at 45 and not any other degree measure. Okay? So that's a sine graph, sine curve right there, rose petals. Okay, a sine rose petal curve right there. Looks beautiful, doesn't it? And again, if you're unsure, you can always check Desmos. All right, throw it up on Desmos and see where you should begin. No fault in that. Okay, so there's a sine curve. So let's talk cosine right now. Take a look at this bad boy. 4 cosine 3 theta. All right, so first thing I'm going to ask you guys, how many petals should it have? Okay, well, we look at this number right here. Is it odd or even? It's odd, so that means I'm going to have that many petals, 3. How far apart are they going to be? Well, I go 360, but instead of having 4 petals now, I only have 3. So I'm going to start at, well, not, I'm going to have them 120 degrees apart. Last thing, where should it start? Remember for the sine curve, we went halfway between how far apart they were? Well, for a cosine curve, this is easy. For a cosine curve, you always start at 0 degrees. Okay, always start at 0 degrees. Always. Okay? So here we go. I'm going to start at 0. I got 1 at the origin. How far is it going to come out? Well, what's the number out in front here? It's a 4, right? So it's going to come out to 4. 1, 2, 3, 4. Cosine curves always start at 0 degrees. Now, I got to figure out how wide is the pedal, right? How wide is it? So I have to go to the left and to the right here. All right, to the left and to the right. And I know it's been a while since we talked. All right, but remember they go by pi over 12. So that's going to be pi over 12. The one to the right here is going to be, there's 24 of them, so this will be 23 pi over 12. And that's, you can remember that now, okay, because that'll always be the same. So I go to my graphing calculator. I do 4 cosine, not going to screw it up now, 3 times alpha y equals pi over 12. And it's going to be about 2.8. All right, so this is why I gave you a blank canvas here, so you could write it in yourself. Pi over 12 is going to give me about 2.8. Okay, and then if you do 23 pi over 12, watch what happens. 4 cosine, 3 times. Gotta delete that out there, that 3. 23 pi over 12. 2.8 again. Okay, so at 23 pi over 12, it was 2.8. Okay, so to the left and to the right, we're going to graph 2.8. So 2 and a little more. Same thing over here. Okay, graph it in. There's pedal number 1. There's pedal number 1. Remember, we got 3 of them, 120 degrees apart, remember. 120 degrees apart. So remember, every time you go a little mark, it's 15 degrees. Probably should have mentioned that in number 1. It's 15 degrees. Here's 90 degrees. So this would be 105. Here is 120 degrees right there. So I need to plot my other one right there. It goes out to 4, as we know. 1, 2, 3. Whoops. 1, 2, 3, 4. And then you got 2.8 to the right, 2.8 to the left. There it is. Okay, go 120 more degrees. You can go by 15s. You can know that this is a $1.80, so that's 195. I got to go 120 more degrees, so I'm looking for 240, right? I'm looking for 240 if I have to go another 120. All right, let's keep grinding here. That's going to be, let's see, 210. This is going to be another 15 degrees would be 225, and then we finally get to 240 down here. Okay, so I'm going to go 4 units out here. 1, 2, 3, 4. 2.8 to the left, 2.8 to the right, and our final petal is now graphed. All right, looks beautiful. Okay, looks beautiful. So again, if it's a cosine graph, it starts right at 0 degrees. If it's a sine curve, I got to figure out how many degrees the petals are apart and then cut that in half to figure out where I got to start it. Okay, so that was the big difference between cosine and sine. Guys, everything else we've done in the past, just fill out a table. Okay, these are the only type where I need you guys to know some facts about it. Okay, so let's get after it. You guys can always ask me questions at the meet. You guys know that. I got 2 cosine curves working here. It looks like 2 cosine curves. Sorry. This should be a sine curve. All right, so please, it's in here like that. So please change that to sine 3 theta. Okay, so I want you to graph a sine and a cosine for me. All right, guys, good luck.